it's still that really weird thing that I still have to go, headphones on, the exits are here, everyone got them all loud and clear. Lovely. Sorry, we are running a few minutes over. We just had some bits and pieces to sort out to make sure that this session goes with a bang. We've got somebody joining us virtually. So great big welcome back. This is the design session. I am going for a gin and tonic now because we have the best moderator. I'm out of a job now. Please give it up for your moderator for this session, Research Director from MMIS. It's Chris Dungy. Over to you.
Thank you for that warm welcome, Sally. Very much appreciated. Just checking, can everyone hear me okay? Everyone's all good? Brilliant. Well, good afternoon and welcome to the next panel and Q&A session entitled Design Casting the Longest Shadow Through Life. So as Sammy said, I'm Chris Dungy, the MMIS Research Director, and I'm your chair here today. Over the next 40 minutes or so, we will hear from a number of expert and pivotal voices from the UK engineering community. And then we'll be conveying and discussing key messages on the role that design plays on sustainability, and importantly, how we now need to think very much differently on the approaches to achieve a real carbon emission reduction target. So hopefully you'll see the poll, Sammy. Has the poll come up live? Can we launch the poll, please? Is it all good? The poll's up here. So this part of the session, I'd very much like to encourage you to go onto the app. There's an ability here to vote on this question here and also ask questions as well. And then we'll be picking these up at the end of the session. So please feel free to start playing about with that app now. So the polling question there is, what do you consider to be the most significant design consideration in your organisation right now? So I'm just going to say a degree of context for this particular session before we drop into the main event, as it were. So the biggest influence on life cycle costs and environmental impact is the design aspects. Design decisions such as material and manufacturing process selection, geometry optimization, design life, ease of repair, and ease of recycling all have a direct and indirect impact on the sustainability of a component, a product, and the entire system that it interacts with. But these complex and interrelated factors need to be thoroughly considered and early decision making made within the design process. This is to achieve, of course, the necessary design and delivery milestones, with many aspects and their impacts still not fully known at these critical early stages. As such, these early decisions are extremely difficult and costly to fully achieve and execute effectively. So that's one of the key aspects here. However, net zero targets are driving technological disruption and innovation that has not been seen for decades, and will require significant investment to enable the right kind of innovation to create the products and systems necessary for this new world. Some examples in this context are electric and hydrogen power for transportation, production of electricity for hydrogen, batteries, fuel cells and electrolyzers, and so on. Also, distribution and storage of energy from point of production and point to use is critical. So I'd like to encourage you all to use this great opportunity to raise some thought-provoking questions of our panel and of course yourselves around thinking and acting very differently if we had to achieve our net zero vision. So without further ado, what I'd like to do now is offer a very warm welcome to our panellists today. So give a round of applause to Bradley York-Biggs of the Institute of Design Engineering. Bradley. Next up is Stephen Gregson from Rolls-Royce. He's a virtual attendee. So Stephen, hopefully you can hear us. Then we've got Will Mitchell from the 4C Design Limited. Will, nice to meet you. And then of course, last but not least, Dara Dash from Williams Advanced Engineering. So Bradley, if you'd like to take the stage, I'll just do a brief introduction. So Bradley York-Biggs is up first. He's the CEO and Professor of Practice at the Institute of Digital Engineering. Bradley leads IDE and Digital Engineering Spaker Advanced Propulsion Centre. He's the chair of the Automotive Council's Advancing Digitalisation Mission. He's chair of the Digitalisation Culture and Working Group, an automotive lead for the Brunel Challenge. I need to take a breath here. There's quite a lot here. Bradley is an expert speaker, has over 30 years experience in the automotive and technology sectors, particularly with Aston Martin, Ford, Jaguar Land Rover and BMW. So good, warm welcome to Bradley. The stage is yours.
Thank you. Thanks very much, Chris. First thing is an apology. Within the automotive industry, we tend to use the word engineering instead of design. So if I keep talking about engineering, I mean design. Within Aston Martin, the designers are the ones that go for the Royal College of Arts. and hold the felt tips and choose leather materials, where the engineers are the ones that sort of do what you call design. So if I, straight away we sort of just get that language sorted out. When I talk about engineering or product development, just read design. So as Chris said, most of my background is in the car industry. A lot of the examples I will use are from the car industry, but very much they relate to many other industries as well. In fact, what we're facing in the car industry at the moment is a massive challenge on a number of different fronts, some of which I'll go through today. The biggest challenge is actually shared by most manufacturing sectors, and that's the fact that most of the platforms or architectures that we use today or rely on today, whether it be a train, a plane, a power station, or indeed a car, were actually architected in the 50s and 60s, which is frightening, but that is true. And those architectures and platforms are now beyond their point of hysteresis and are no longer capable of providing the market needs, the societal wants, or indeed, very topical as we're in Glasgow, the environmental imperative. They are literally at the point where they are not useful enough in providing societal needs. So there's a global race going on, and we're seeing that in every sector, to create those new architectures that we're going to rely on for the next 50, 100 years. So within the automotive specifically, I guess this is when I do this, it's a double-edged sword. We are facing unfathomable levels of complexity, not due to electrification. Everybody says electrification, batteries, gigafactories. Yes, that is important. That is not the straw that's breaking the camel's back. It's the level of software, the exponential growth in software within products, within our cars, that is the unsurmountable problem at the moment. A modern day family saloon car is more complex than an Airbus A380. It has over 120 microprocessors, when we can get hold of them, and over 120 million lines of code to keep you safe on your road and to where you want to go to. So a lot of people don't understand that. Your modern saloon family car is a highly complex beast, and it's only going to get worse. As we, as society, demand more and more levels of autonomy, as we move to level 5 autonomy, i.e. the car drives itself, which is some way away, we're going to have 2 to 3 trillion lines of code at your disposal in the platform that you put your loved ones. Now that's scary enough, but when I tell you today's code in the car is about 2% what we call risk code, i.e. if it goes wrong, you're in a spot of bother. In a level 5 autonomy car, you're talking 20 to 30%. So the real challenge is, how do you validate, verify, and certify that level of complexity from a software perspective as part of an engineering program? So that's problem one. I will come and try and give you some ideas of what the answer is in a minute. Level 2 is the mobility and transport market is moving at such a pace, we no longer have 5 years, which is generally how long it takes to engineer, develop and launch a car, to do that anymore. Conceptualize, engineer, validate, assure, manufacture, distribute. 5 years. We've got to get that down to 2 so that we can be much more reactive to a very emergent mobility market. And that's the same in the aerospace industry. We need to get developing a new aircraft down to 5 instead of 9, a power station to 10 instead of 20. We've got to be more nimble in the way we bring product to market. And the UK has to be at the front of those new levels of productivity. No longer is mechanical components or commodities the critical path in developing a product. It's software. Actually, electrification makes a car an awful lot simpler. There's less moving parts. An internal combustion, let alone a hybrid car, is the worst of all worlds. Full electrification mechanically is a lot simpler. The challenge is software. So I think I've only got one slide anyway. So those are 2 challenges. The third challenge, is one which we're struggling with in the automotive industry at the moment, is we've got to start thinking beyond a car. Okay, we've got to start thinking about future mobility solutions, where we need to take into consideration energy supply, distribution, infrastructure, telecoms, and make better decisions as part of the design engineering process up front, cognizant of how that product's going to be used in the marketplace, how we're going to dispose of that product, what materials it's going to use, what is the drive cycle. No longer can we develop a car, fire it at the manufacturing team who'll make it, who'll fire it at the marketplace, and then warranty and service department will figure it out after that. We've got to get much better at looking at the whole life of the product and driving better decisions at the front end. How do we do this? There's a clue in what I do, and that is digital. Design does not throw the largest shadow, or will not in the future, across the whole life cycle. Data will. We've got to find a way of moving 50% to 80% of what we do in the physical world today into a trusted, correlated, appropriate fidelity digital world. If you look at a new Range Rover program, it's about £1 billion. I'm going to use big rounded numbers here. That £1 billion, 42% of that roughly is both from a time point of view and from a money point of view. So over 400 million is consumed with flying prototypes and testing 3 series of prototypes in series around the world. It's not very efficient. We've got to move much of what we do from an engineering point of view into that digital world with new advanced levels of modeling and simulation capability. We need to use new science and technology like artificial intelligence, specifically machine learning, to actually better digest the data we get. We're not short of data in the car industry. The product you drive has loads of data coming off it. What we've got to do is harness that data, create insight from that data using machine learning, and then make better decisions as engineers for both our customer, for society, and obviously the planet earlier on in that process. So that's the challenge, is digital tools and techniques. So like I said, I'm pretty much almost out of time. The key is we shouldn't be looking at any individual item of the life cycle. We shouldn't say manufacturing is the most important part or design. The key is to look at the whole life cycle, create a digital thread, look at the whole life of data across your product, across your enterprise, across sector, and make better decisions. I think I'll stop there, and I look forward to hearing your questions as part of the panel. Thank you.
Thank you very much, Bradley. Appreciate that. Some really important messages there, particularly around the systems-based approach. So thank you very much. So over to our next speaker now. Hopefully it's working online. Can we just confirm? Steve Gregson's
yeah.
Online?
Can you hear me?
Hey, Steve. I'll just do a brief bio, Steve, then I'll hand over to you. So warm welcome, Steve. So Steve is the Engineering Fellow for Services at Rolls-Royce, where he has worked for over 33 years. He's also the Industrial Co-Chair for the UK Pre-Life Engineering Services Council. Steve is a mechanical engineer whose career spanned the full life cycle from new product development to services support. He is the architect of the Project Zero programme in Rolls-Royce, which seeks to maximise customer availability whilst minimising life cycle costs. So over to you, Steve. You've got several minutes. We'll catch up very soon. Thank you.
Brilliant. Thank you, Chris. So it's great to be here, even virtually, and maybe I should have had a mannequin of some sort, or a hologram even. But anyway, so today I'm going to explain how an aftermarket business model can affect sustainability and why outcome-based services are generally better. So what do I mean by an outcome-based service? So it's basically a business model where you're paid and rewarded on the basis of a customer outcome. It's as simple as that. Everything as a service was the theme of a recent 3-day conference at the NEC, Servitization Live. So this stuff is spreading quite wide and far and wide. Rolls-Royce are the pioneer of this type of thinking, and we set up Total Care many years ago now. It's otherwise known as Power by the Hour. And it's been the subject of many services case studies. So if you pick up a book on services, you'll generally find out about Rolls-Royce in there as an example of best practice. So what I'm going to do today is share some insights and some secrets from what makes that tick through some videos and some stories about what makes it work. So currently, our customers typically own the assets. So there's a misconception that we just get paid by the hour, but they actually buy the assets at the outset typically, or lease them from somebody. And we get paid for each flying hour that takes place in service to provide comprehensive aftermarket support. And that includes maintenance, repair, overhaul, that type of thing. We work closely with our airline customers through things like Project Zero to make sure they can take off and land on time every time. And that enables their customers, which is us, to do what they need to do with confidence, get to their destination, get to our destination on time. So we give customers a choice. It's not mandatory that they take Total Care, but compared to traditional time and materials business, where we would charge per hour of maintenance or we charge for spares, generally, the vast majority of customers choose Total Care. I think it's in the 95% territory for the new product. And we're constantly looking to innovate for new ways of making total care leading edge, state of the art. And we're looking at new thoughts around what an advanced service looks like to be truly outcome based. And this is just one aspect of Rolls-Royce's net zero sustainability strategy. So I'm here talking about an aerospace example, but we're very busy working with partners like Shell to set up sustainable aviation fuels. We're looking at developing electric propulsion to replace gas turbines for short haul. And we're looking at developing fuel cells and small modular reactors for clean power. So there's a broad, diverse portfolio of activity. Okay, so next slide, please. Okay, so if you look at what makes an outcome-based service tick, we should be able to see a slide on the screen. Anyway, I'll keep going because it's fine. So basically, in order to, an outcome-based service encourages to maximize the life of assets in service by focusing on what we can do to avoid problems in the first instance by better design. We look at the way we make the parts, and we look at the way we operate them with the customer. Anything that does happen in service, everything needs maintenance at some point. We need to coordinate that, and we put effective containment in place across the fleet through effective service management. We recover assets back into use through effective maintenance, repair and overhaul. And all the while we convert the learning that we gain by doing all that back into process improvement and better design again as you go back around the cycle. And these are all highly symbiotic with the sustainability drivers of reduce, reuse, recycle. And if you saw the chart, you'd spot that. Oh, you can see it. That's great. Thank you. Okay, so if you play the video, please. So let's have a look at what that looks like in practice, starting with the design. So if that took it, there you go. We are obsessed with how these things perform from an efficiency point of view, but also how they deteriorate through life in operation and what drives the useful life of them. The high pressure turbine blade, which you can see now, is right at the heart of an engine, and each blade generates the same power as a Formula One car, and there's 72 of them in one engine. So you can imagine how powerful this is. They operate at temperatures well above the melting point of the metal, and the blades are cast in order to cope with that as a single crystal of metal, using a wax mold to shape the inner passages. The blade roots, as you can imagine, are spinning at high speed under huge stress at very high temperatures. So precision machining is absolutely essential. And we use lasers to drill holes through the aerofoils to allow air from cooling passages to escape and flow across the aerofoil surface to provide a boundary layer effect. The system operates with really tight running clearances to maximize efficiency, and any one of these stages from the beginning to the end can drastically affect the performance of the life of the product in service. So to the point made earlier, we use digital very heavily. We have a digital twin of the product to optimize the design, the manufacturing and the assembly processes to get it to perform better for longer, fundamentally. And access to comprehensive data from all stages of the life cycle is absolutely vital. So the data you capture by inspection through manufacturing is vital to helping us understand which engines are going to suffer from what problem in the future. We would be less focused in general on extending life and repairing parts if we had contracts that incentivized us only for charging for maintenance hours and spare parts sales. And that's why Total Care helps with the sustainability incentive. So once it's in service, once the product's in service, the digital technology that we use allows us to treat every engine as an individual. We tailor maintenance schedules and to the measured operation rather than just applying a one-size-fits-all approach to the maintenance policy. And our customers benefit from our understanding of the whole fleet, not just their own, and that helps reduce risk. It helps maximize availability of the aircraft for them, and it helps with operational efficiency, fuel burn, etc. And we call this whole thing the intelligent engine. So if you click onto the next video, please. So we control all this and coordinate it through our 24/7 aircraft availability center. Our engines travel the equivalent of 20 times to the moon and back before needing a major overhaul. And you can compare that to your average car, and it's somewhat stark. But when it's time for some maintenance, we do what we can either on the wing or near the wing. And we've invested very heavily in remote collaboration capabilities. And this enables us to connect our specialists back at base and headquarters directly with the people doing the work on the flight line. anywhere in the world, any time of the day. And we're always challenging ourselves to find innovative ways, new ways, different ways to maximize customer availability, because that's really what matters. And a great example of this is our latest boroscope capability, which is called the Intelligent Boroscope. And it's the first example of the application of artificial intelligence in a live inspection capability like a boroscope in aerospace. And it provides a vital service management capability by transforming how our understanding of used parts in service and how they're performing. We've even developed snake robotics, which are able to get through a 9mm boroscope port and reach several meters inside the engine to perform tasks like laser ablation of damage, as you can see on the screen. So if you go to the next slide, please. Okay, so during a major overhaul, we reuse and repair what we can as part of the contract, and we revert most of what we can't use back to raw material, which is a great opportunity to close the loop back to producing something useful again from what's served 30, 40 years of service operation. The overhauls take place about every 5 years on a large engine, and that gives us an opportunity to inject new technology and upgrade the products. And generally, products managed under total care are of a higher modification standard than those which aren't, because we're incentivized to keep them to a high standard. So if you go to the next slide. So just to summarize, the move to an outcome-based service model does put strains on different parts of the organization compared to more traditional business. Things like physics-based lifing, product maturity, risk management, supply chain logistics, material supply, cross-functional data flows, and finance models are all strained very differently under this type of contract. But ultimately, it leads to a much better alignment between you and your customer. Your objectives are their objectives. You're effectively walking in their shoes. And I hope you'll agree that from what you've seen, it's an inherently more sustainable model. Thank you very much.
With some great examples there, so greatly appreciated. I particularly like the business model angle, supporting sustainability and the digital wraparound as well, and particularly Bradley mentioned that as well, so I think we can maybe touch base on that a bit later. Just like to mention the poll is open. We've got several responses. We'd like to up that number, so let's get way into the double digits, so please open up the app and answer the polling question. Next up, Will, if you'd like to take the stage. So Will Mitchell is the Managing Director of 4C Design Limited here in Glasgow. He has over 25 years experience across a range of sectors and industries. Alongside his team at 4C, have successfully developed and launched a range of products, both themselves and international client base. So welcome to the stage, Will. You're going to need that one.
Oh, super, thank you. Thank you very much. Let's stick this up. So, as Chris said, MD of 4C Design. We're a business that's nearly 20 years old, and we've worked in a whole range of industries and with a whole range of businesses, from startups, kind of medium-sized businesses and large-scale companies. And I was thinking about this as a talk, and the idea of design casting the longest shadow, it feels like quite a negative connotation. And it kind of is, and there are statistics to kind of back this up. In the startup world, new product-based businesses fail at an astonishing rate. It's kind of over 90%. And that's really quite harrowing when you think about the amount of effort that it takes to actually start a business and get these things going. And it's kind of this I want to focus on, because as designers and engineers, we have a responsibility to make sure that that doesn't happen. And a traditional design process, a consultancy might be brought in at a kind of late stage when all the major decisions have been made and they've done the research and they've worked out where they want to be. And sometimes, and in most cases, that's too late for a design consultancy to come in. It should be right at the beginning. And this kind of oversimplified chart that you're seeing is really just to try and make the point that actually at the very beginning you can make lots of quick decisions, and they're cheap and easy because you're talking about speculative, conceptual stuff that still has that agility to change. And it's not very expensive. I mean, we're talking about maybe a one-off, two-off prototype, bit of interviewing, all that kind of stuff to get a feel for a product. And so all of this can happen at the beginning, which is why as a consultancy, we like to be brought in at this stage and not later. So I would be the pane that comes in and says, have you thought about this? Do you know where you stand on things like sustainability? Do you understand what the consequences of this product are? And thinking about your market, are you thinking about who wants this and why? Is it a necessity? I'd rather talk myself out of a job than go ahead with something that doesn't feel right. And I think the reason why it's important in startups specifically is because these are the big companies of tomorrow, and these are the companies that need that guidance now. For some cases, big companies that are already, they've got an agenda and they will work on that, but for the startups, this is much more important. So when we are working with these companies, we want to be asking those questions. We want to be digging in and finding out what are the consequences of these decisions at the early stage. We look at the concept phase, we look at the design and development phase and the knock-on effect that these decisions have in manufacturing and beyond. Because what you don't want is a product out there that then gets returned or has complaints or has a real problem with customer care. So again, getting in at the beginning, asking those awkward questions and being the person that really wants to tap into that is what this is all about. As we kind of go through that process, we get to a point where these kind of lines cross. And that is your decision point. That's the point where you really want to be saying, right, we're committed, we're going to go forward with this design. I mean, the statistics, they really grind me down because it's a case of we want to see a massive improvement in that. And you don't want to be at that crossover point where you're making those decisions and you've still got the wrong product. The other major factor when it comes to failure of these companies is when they are considering manufacturing and they are considering manufacturing too late, they're asking for more money. And that's when people start to say, you know, that wasn't part of the deal, or this is more than we anticipated, and that's where a company can fall over. So again, at the beginning, we should be talking about manufacturing, we should be talking about, you know, distribution and the support going forward. So at this crossover, we see the design actually manifesting into something that needs to be manufactured. And that's when we start to really engage with those people that we've already been speaking to but are going to implement that and take it forward. And as a designer and engineer, I just feel that responsibility, and I want to make sure that these decisions are made going forward, because the long-term effect is that we could have a very good product out there, something that people enjoy using and look at and say, this is very clever, we love it, and all of that kind of stuff, because that's the positive side of casting a long shadow. And so, for me anyway, what I want to see is a massive change from a 90+% failure rate in these startup companies to a 10%. Let's be really ambitious here. I mean, design intervention at this very early stage of the process is not the silver bullet that's going to solve all the problems, but it's going to de-risk the process. And with the experience of companies like ours, we are asking the right questions. We do have an agenda here, which is to see a better and more sustainable future through product design. So for me, that's kind of where it needs to start. With the big companies, we work with those as well, but they have the agenda. We can help implement that. We can helicopter in, we've got fresh eyes, and that's a great set of attributes to have. But for the startups, this is kind of a big day for them, and it's something that we need to be addressing, and now. So, thank you very much.
Perfect, Will, great timing. Thank you very much. And some really good insights there about setting key challenges early on, the consequences of getting it wrong and the impact on failure rate of businesses. So some really important messages there. So last but not least, Dirk Ardash, from Head of Automotive Business Development at Williams Advanced Engineering, will join us very shortly on the stage. He's a graduate of automotive engineering, has over 20 years of automotive-based industry experience. He started his career at powertrain development at Ford Motor Company. He also joined Denso as well in 2001, where he developed electronic powertrain control and fuel systems for several European manufacturers. Dirk holds both the chief engineering and senior commercial roles at Ricardo before joining Williams. Has now been involved with winning and delivering projects globally in a variety of technology areas, across products and from passenger cars to constructions. So over to you, Der, for the final presentation.
Just a bit of a role introduction for me. My role is all about collaboration, making sure that a lot of the organisations that we have here today, whether or not they're customers, suppliers, academic institutions, work together to fundamentally deliver a more sustainable future. For me, it's all about joining the dots. And WAE, Williams Advanced Engineering, if those of you don't know anything about us, we are the engineering arm of the Williams Formula One team, formed in 2010, and for the last 10 or so years we've been responsible for delivering a number of sort of groundbreaking projects within electrification, but still using lightweighting and our background in aero and thermal capability to deliver those. One of the wonderful products that we've been working on is a wonderful Triumph TE1 that you saw on your entrance here. We did the HV battery for that, and again another instance of real collaboration. So does design have the longer shadow? Well, I'd probably say yes. I know Bradley suggested something different, but actually I think the implications that Will mentioned right at the beginning of the concepting of products really makes a difference. Actually, there are many things that need to happen, and joining the dots is really important. So, first of all, consumer intent. If we think about what annual climate savings are for individuals and households, we can understand that, moving forwards, 20 years ago maybe we weren't using energy saving light bulbs, but clearly that's made progress. If we switch to an electric car, that will also make progress. Actually, the problem with that is it's about 50,000 kilometres where it will really make a difference to greenhouse gas emissions. Avoid one transatlantic round trip per year makes a significant amount of difference as well. Live car free. I think once we start going into transport as a service and autonomy, I think that is going to become a reality over the next 10 years. And last but not least, have one less child. Now, I know that is quite a significant impact to many people. And when this was discussed around the Ardash family dinner table over the weekend, my firstborn daughter, who's 16, turned to us and said, "Shouldn't have had Charlie." Clearly that's not really possible, but I think consumer intent really drives what's happening. And I think legislation and government bodies really make a difference there. What we need to do as well, and I've seen lots of really positive stories around the booths, is design for material ecologies. So this is, while circular, this is really a linear economy. You pull raw materials out of the ground, you manufacture, you distribute, you use, and then you get rid of. That happens all the time. Now, things are changing. What we really want to see is second use, and maybe third use, and then recycling. That will make a significant difference to what is happening for the future. However, even today, the majority of the products that we see in the marketplace have not considered this at the point of design. I think what we need to be doing is considering it up front. More collaboration is required across the different functions, whether or not you're working within design, manufacturing, recycling, reuse. It's a really important element. The good news is, and I'm very fortunate to speak to many different manufacturers, is that this is absolutely on the agenda. From now, I'm seeing more and more organisations thinking about second life, third life, and also the ease of recycling. Designers or engineers, actually, I think they should be called sustainability alchemists moving forward. And the reason why, previously, a designer or an engineer would design for function and maybe design for manufacture, but not necessarily considering anything else. From day one, there needs to be the consideration for designing for resources, for the environment, for societal impact, and recyclability. Gone are those days where you're only designing for one function, and understanding, and this is an important point, the system within the system within the system is really, really important in terms of delivering a sustainable solution. I really like what Bradley was talking about with regards to digitalization, because that will only compress the cycles. That's only going to be a good thing, but we still have a huge challenge. And the key point for this, and hopefully this slide summarizes it all, is that joining the dots of all of those things will really make a difference to a sustainable future. Thank you.
Thank you very much. Brilliant, Steve. Okay, should we now bring up the poll? That concludes the panel presentations. We're going to go into a Q&A session now. All right, so how are we getting on? 26 votes. So, like the panellists, have a quick look at what's going on here, and I'll go around the panellists very shortly to get their thoughts on what they're witnessing. But what do you consider to be the most significant design consideration in your organisation right now? Obviously, a big bias towards design for manufacturing, design for life as well, and material selection have come up. So, anyone would like to make an initial comment? Maybe Will?
I suppose, given how much, given how much importance I'm putting on at the very front end, I think this design for life is a really important part, because essentially, when you look at what it is you're trying to produce, you really do have to ask yourself the question, is this going to contribute? Is this going to be useful? Are people going to use it? And all that kind of stuff. And it's kind of the thing you should be asking right at the beginning before you get into any of the questions regarding manufacture and stuff. So for me anyway, design for life is the one I would put the stress on.
Thank you very much. Dave, could I?
Yeah, absolutely. I'd agree with Will there. I think connected to what I was just saying, it's across not only the first life, but the second life, the third life. And I think the key point there is that all of those other elements are included within that. For me, function, aesthetics, material selection, all contribute to design for life. And as I said, second, third, fourth, and the recyclability.
Very much. Bradley?
Yeah, I'd love to be controversial, but I agree. Design for life. For a slightly different reason, I think it has to be designed for life. I think the challenge becomes it's always a balance and a trade-off. I mean, as you put on your slide, there are many things now that we have to consider in those early stages of our concept, and it's how you balance those attributes. You cannot hit them all, and you need to make better decisions for your business and your customers much earlier on in the process. So you need to find a way of finding compatibility for what your brand stands for and what you're trying to put out there, whilst balancing those attributes early on in that process. And obviously the better you do that and the quicker you do that, the more successful you'll be.
So do we think the design for life maybe, is that specific to the original use or intent of that product, or should we be considering
No, I think, I think you've got to be careful what you're trying to chew off and what you're trying to balance. I think in an ideal situation, I agree, you should be encompassing not it's just its first life, its second life, its third life, if indeed your product has. But you just need to be careful to define your scope and not bite off more than you can chew. But obviously the more you can build in around what attributes you're trying to balance, the better.
Brilliant. Steve, would you like to make a comment if you're still on?
Yeah, no, I agree with everything that's been said, but I would just like to add that these things generally take financial incentive to actually sustain and make happen. And therefore connecting it into how you're going to make money through the servitization type model, for example, is a very good way of closing the loop and aligning the incentive, because it's then in everybody's best interest for it to last as long as possible. And with the wrong service model, it can be the other way around.
Thank you very much, Steve. Just following up, getting on to the panel discussion now in terms of the app and what questions have just been raised. So one's come from Russell Teeling from Rolls-Royce. Russell, are you? Put your hand up. Russell's over here. Would you like to ask your question? I think Dermot has some great insights here. Sorry. So your question was around how do we change the mindset of designers to think net zero manufacturing and life cycle?
Working in manufacturing, we have to deal with some of the problems of trying to manufacture designs that are difficult to manufacture and can have a lot of waste of material, time, energy associated with them. So how do we close that loop is my question to design guys.
Anyone in particular? General question?
Yep.
Ken, Will, I'm looking to yourself to answer that one.
I think it's a very real problem. As I said, one of the there's two main reasons why, for example, small businesses or startups fail, and one of them is they are designing the wrong product, they haven't done their homework. But the second one is they haven't really worked out how they're going to make it. And in some cases that can be a huge investment. And if they're trying to raise that money later, they may come into problems. So for me, it's about establishing those relationships as early as possible. So if we're talking about a product that is to be mass produced, then what is the most appropriate way of doing that? And to bring these experts in as quickly or as early as possible. In some cases it can have a knock-on effect, which is those people may want to push a technology which is more suitable for them, and that can be detrimental as well. So it's about a balance, but for sure it's get them in as quickly and as early as possible.
Very good points made there. Yeah, particularly picking up on your alchemist. I was fascinated, particularly my background in metallurgy and material. So alchemy's reared its head as it.
Yeah, absolutely. I think that the key point is getting people together as soon as possible. To add on Will's point, for me, designers of the future are not necessarily going to be incredibly capable in one specific dimension, but they're going to be able to take a step back and try and understand all of those different facets. So bringing design, from a manufacturing perspective, DFM into the discussion. It has happened over the last number of years, it's no question, but I think there's so many other factors to consider. And then unfortunately, we have this commercial challenge that sort of overcomes it all, where clearly we want to get to market faster on product, and those life cycle, those development cycles are happening ever faster. Hence the reason why we need digitalisation to do that.
Thank you, Dave. Steve, from a aviation and Rolls-Royce perspective?
Just add something. So we said at the beginning that design casts the greatest shadow. I think leadership casts the greatest shadow, because the questions the leaders of the organisation ask the community, the design and manufacturing communities about what's being developed, are the things which will then influence what they focus on. And if nobody at the right level in the organisation asks about the sustainability or the manufacturing or the servitisation side of it, then guess what? You get what you get, and you get the function, but you don't get the rest of it. So I think certainly from a cultural shift perspective, leaders need to be asking more of the right questions.
Very good point. Bradley, would you like to come in on that?
No, I like that answer as well, actually, about leadership. But I think the other bit is, I think, again, from a digital perspective, I think it's, again, designing for quality, whether that be product performance or whether that be manufacturing quality. I think there's more we can do. For example, and the manufacturing engineers are going to like this answer, but to build the bill of process essentially into the engineering tools up front, so that we fundamentally are driven to make better decisions and better attribute trades as part of the engineering process, that manufacturing will naturally pick up the benefit when it lands with them later in the process. So it's building our simulations and models to understand and give us the ability to react to the manufacturing environment that we're going to be producing it in.
Brilliant, thank you very much. I think we've got time for one more question. We're running out of time. Andrew, Stephen, I'd like to come over to you. Would you like to pose your question to the group? It's particularly interesting in light of who's in town, as it were, from a global community, particularly the UK and Scottish Government. So over to you for your question.
Yeah, from a... You hear that?
Yeah.
From a design and engineering perspective, what would you like to see UK government do to support the acceleration of design engineering and the net zero future products? Because it's that front end of the S-curve that needs to be compressed. We don't have the time. Then we get to 2035, 2050. What would you like UK government to do to support us?
Yeah, Bradley, please.
I think it's an excellent question. If I may say so, and it's one of my bugbears as well. But I will be quick. We are a nation of great innovators, and it's great to see the government's agenda, trying to strengthen us and be innovators. But we've got to remember that engineering design is innovation's bridge to economic impact. It's great at inventing stuff, and we've done it numerous times over decades. But unless we land it, unless we in the UK can take those innovations and engineer it so they are fit for consumption by society, and create the manufacturing footprint and the value chain footprint around that initial innovation, then we'll lose our industries within the UK, because somebody else will be able to do that faster. So What I would like to see is more focus from a government intervention perspective in bringing the innovation to market in that sort of TRL to TR7, so TL7 perspective. That's where we're not focusing enough.
Just probe that a bit further, Bradley. It's some big initiatives that are being developed in like the Brunel Challenge. Do you see that as a component?
It is. I mean, without getting too geeky, the Brunel Challenge is the other side of manufacturing made smarter. So at the moment we have a big initiative, obviously made smarter, which is around digitalisation of our manufacturing process. What we haven't got is the bit we're talking about today, which is any government initiative which is focusing on digitalising our engineering. So make that upfront piece and actually joining the whole lot together, because that's where the holy grail actually is. But no, we don't. That is we're still trying to wait for an answer out the spending review and out the budget, and it's still not clear. But at the moment, we do not have any specific programs helping develop national programs that give us that bridge from our great innovations into industry.
Thank you very much, Bradley. We've now run out of time, but I'd like to offer the panellists. Anyone else would like to come in on this topic? Steve.
No, that's fine.
Can I be slightly controversial?
Oh, I like controversy.
I completely agree with Bradley. I think that's one of the gaps that we're not able to scale in this country compared to some others. So TRL 4.5 to 7, I think, is absolutely apparent. One of the things I'm going to say is I think there needs to be more incentivization on the ends of the traditional linear economy. And what I mean by that is at the consumer. So there needs to be more incentivization at the consumer end, and there needs to be more incentivization around recycling and reuse. Actually, I think all the fantastic people in this room will find a solution for the middle bit. Those are the important elements for me.
Very good words, thank you very much.
Just, I suppose quickly is the idea that businesses are bringing in, designers at the C-suite level, the sort of chief of design, and I feel like in government we probably need people with more frontline experience in development and design to actually be advising, and more of a kind of hearing what's happening on the front line and bringing that back. And obviously our industry needs more support and at all parts of the process.
Thank you very much, River. Well, sadly, that brings us to the end of this session. So what I'd like everyone to do is give a big round of applause to our guest speakers today. So thank you very much for your time. Thank you, Steve. Online we'll talk very shortly, and I guess I'll hand back to Sunny.
Great big thanks to Chris for moderating. Give him a round of applause. It's not an easy job. And especially when we were running late. Thank you so much. We have time for a short break. I know that Stephen is leaving us because he's zooming off, pardon the pun, but I know some of our speakers are staying with you, Chris, as well. So I know Colin asked a question, a couple of other people asked a question, Rosa, Andrew, go speak to these people. We will get those questions answered, right?